Good afternoon, everyone. We are students of the Government Technical Institute, and we are in the course EMMM, Electrical Major and Mechanical Major students. And this evening, we would like to present on the firefighting robot. And this here is the first model in Guyana, and we would like to present to our viewers and all the listeners about more about this project and the benefits of having it in the country, the third world country like Guyana. And I would like to introduce our members. This is Ray Moulter, Evan Wiggins, and Akaya Griffith, and I hand you over to Ray Moulter now to speak.
Good afternoon, viewers. We're going to be explaining to you how we came about with the idea to develop firefighting about consent here. Now, there are also third world country, and we don't have a lot of, or not even a lot, we don't have any money that will be investing in firefighting robots, automated firefighting robots. All they would be investing in is fire extinguisher that would need to be used by humans, handled by hand, to be able to out fires. So now, if we have a robot that will be able to approach the fire without human intervention, we will be able to save a lot of lives and be able to keep firefighters from being injured. Also, we'll be able to call the fire before it gets out of hand. Now, our project is not the first to come about. We got different creators that have different firefighting robots. The Formite that was built by Howard Howe. That's a advanced firefighting robot that was used in a fire that was used to out a fire in Paris. The firefighting robot costs roughly 60 million Chinese dollars. That is 277,000 USD. Now, a lot of homeowners in Ghana will not be able to afford purchasing a robot like that for home use. So we decided to build one that is low budget. Now, this robot was built using parts from the Arduino kit. We used the board to program the driver motor. We used four DC motors. We use wheels. We purchased four wheels. Use breadboards. Use water pumps. Use motor drivers. And we use a bowl, or we could say a can that would hold the water. And we use a metal plate that that would hold all the parts for the robot. Now, our robot would only cost roughly $20,000, like $100 US.
These trees here are the flame sensor to detect the fire, as you can see. Yeah, yeah, this is the microserver this here. So on the spray, now we have four wheels. Each wheels have four DCs motor, as you can see. This is the pump to pump the water. The breadboard, all the connections are here. The wires, so motor driver, Arduino, the tank for the water, power supply.
This is a program called Arduino IDE, and it was utilized to upload code onto the Arduino Uno board on the robot. The first section of the code deals simply with the setup of the pins and assigning the pins variable names. The next section of the code deals with if the pin is an input pin and output pin, also being able to accurately tell the servo what angle to turn at when it's spinning. It then tells the wheels to start spinning. We then deal with those three flame sensors, the right, the center, and the left flame sensor. We use if-else statements to tell the robot what to do depending on how high the value of the sensor is. If there is a low sensor value, then the robot is to turn on the pump and then move the servo at an angle depending on if the right sensor, the center sensor, or the left sensor was the one that told it that it detected the low value. If there is a mid-range value, the robot is to turn right or left to try and avoid it. And then there's also the option that if the range is too high, that it simply isn't detecting anything and for it to continue spinning. There is also a program to tell the motors when to spin to be able to effectively cause the robot to move forward, backwards, turn right, or turn left.